Question 1. If f of x equals e to the x, g of x equals x squared plus 1, and h of x equals f of g of x, then h prime of 3 equals what? H prime would be the derivative of h. So first of all, I'm actually going to find h. This is a composite function it's asking me to find, so I'm going to start in the parentheses. G of x is equal to x squared plus 1. And then to find f of x squared plus 1, I'm going to go into the f function, and wherever I see an x, I'm going to put x squared plus 1. So we are going to have that h of x is equal to e, and instead of x, I'm going to put x squared plus 1. Now this problem asks me to find h prime of 3, so I first of all need to find h prime. This is an e to the u problem, so when I take the derivative of it, it will be e to the u du. So this will be e to the u, which is just e to the x squared plus 1, times du, which would be 2x. Alrighty, now I'm ready to find the derivative at 3. So now I'll just plug 3 in for my x values. And now if I do that, I will get e to the 10th times 6. And so my final answer will be 6e to the 10. Okay, number 2. If y equals cosine 3x plus e to the 3x, then y plus y double prime is equal to. So we want to add y to y double prime, which means I need to find y double prime. So let's find y prime first. The biggest thing on this problem up here is that we do have, this would be like cosine u. So I'm actually going to do the chain rule to get this. The derivative of cosine is negative sine u times the derivative of the inside, which would be 3. And that will equal negative 3 sine of 3x. Okay, and then plus, this is e to the u, and the derivative of that will be e to the u du. So we'll get e to the 3x times 3. And then from here, that was y prime. I need to get to y double prime. So y double prime will equal, again on this one, I'm going to do the chain rule. The derivative of negative 3 sine u would be negative 3 cosine u. And once again, times the derivative of the u, which would be 3. And that will reduce to negative 9 cosine of 3x. And then on this part right here, again, we have e to the u. Just going to bring that 3 down. The derivative of e to the 3x is just e to the 3x times the derivative of the 3x, which would be 3. So this will reduce to 9 e to the 3x. So that's y double prime. But that's not what they asked me for. They asked me to find what y plus y double prime is. So if I take y, which is, there we go. If I take my y, which is cosine 3x plus e to the 3x, and then I add y double prime to it, negative 9 cosine 3x plus 9 e to the 3x. And from here, I notice that I'm going to be able to combine like terms. If I do that, if I put my cosines together, I'll get negative 8 cosine 3x plus 10 e to the 3x. That pretty much is my derivative. I am going to go one more step farther. Since I noticed that 2 would go into both parts, I'm going to factor out a 2. And I'll be left with negative 4 cosine 3x plus 5 e to the 3x, and then that would be my answer. Okay, question 3. If y equals e to the negative x cosine x, then d squared dx squared is equal to what? Please remember that this means the second derivative. So I want to take the derivative 2 times. I do notice that is e to the negative x times cosine x, so we are going to be using the product rule. So this will be my f, and this will be my g. My f prime will be e to the u du, so it's going to be e to the negative x times the derivative of negative x, which is negative 1. And then g prime, the derivative of cosine x, is negative sine x. So I'm ready to find the first derivative. So we'll have f prime times g, negative e to the negative x times g times cosine x plus f times g prime, so e to the negative x times negative sine x. And I guess I'm set from here. One thing that I'm going to do, and I guess you don't have to do this step, but I would really have to use the product rule 2 times. But if I factor something out, I'll only have to use the product rule 1 time. So I notice they both have a negative e to the negative x. So I'm actually going to factor that out. And when I do, I'll have cosine x plus sine x left. So now I do need to take the derivative again. I am going to have to use the product rule, but I'll only have to use it 1 time. So the negative e to the negative x will be my f, and cosine x plus sine x will be my g. So f prime will equal this will equal positive e to the negative x, because I will have to multiply by the derivative of negative x, which is negative 1. And then g prime, the derivative of cosine, is negative sine x, plus the derivative of sine x is cosine x. So taking the derivative again, we're going to have f prime times g, so e to the negative x times g, and then plus f times g prime, negative e to the negative x times g prime, negative sine x plus cosine x. All right, a few things that you could do from here. If you wanted to, you could distribute it all out and combine like terms, but I actually noticed that both parts have an e to the negative x, so that's what I'm going to factor out. So if I factor out an e to the negative x, from this part, I'll just have the cosine x plus sine x left. And then on this part, if I factor out the e to the negative x, the negative is still there. So if I distribute that negative to both parts, I'm going to have plus sine x minus cosine x. And then from here, if I combine like terms of what's inside, the cosines will cancel, and I'll be left with 2 sine x. And 4, y equals the square root of x over cosine x. Then we want to find out what dy dx would equal. On this problem, I noticed that I do have a fraction, so I'm going to have to use the quotient rule this time. So I have an f and I have a g. To get my f prime, I'm going to rewrite my f as x to the 1/2. So when I find f prime, that will be 1/2 x to the negative 1/2, and that will reduce to 1 over 2x to the 1/2, or I'm going to rewrite that as 1 over 2 square root x. Okay, my g prime, the derivative of cosine x, will be negative sine x. So using my quotient rule, whether you do low d high minus high d low, or however you do it, I'm going to do f prime times g. So I'm going to do f prime, which is 1 over 2 square root of x times g, which is cosine x, minus f times g prime, which was negative sine x, and that's going to be all over g squared, which is going to be cosine squared x. All right, from here I am going to go ahead and get a common denominator up top, because right now this is a complex fraction. Actually, let me simplify it a little bit. This is going to be 1. It's going to be actually cosine x over 2 square root x, because I could put this under 1 and multiply the numerators, multiply the denominators, and then it's going to be plus sine x square root x, and that will also just be over a 1. And then I still have all over cosine squared x. I do have a complex fraction, so I would like to get a common denominator. So getting the common denominator would be 2 square root x. I would have to, on this one right here, have to multiply the top and the bottom by 2 square root of x to get that common denominator. So the first part can just stay exactly how it is. Then the second part, the sine x, will stay exactly how it is. Square root x times 2 square root x would just be 2x. And then it's still going to be all over cosine squared x. And then from here, I am going to multiply by the reciprocal, because I have a fraction and it's actually divided by a fraction. So if I multiply by the reciprocal, that is what I will get. And then from here, my y prime will equal, let's see, cosine x plus sine x plus 2x. Well, actually, it's not sine x plus 2x, it's sine x times 2x. Sorry about that, so let's rewrite that part. This will be 2x sine x all over cosine squared x. And there we go. Okay, problem 5. Evaluate the integral of 2 to the ln x over x dx. Right, I see a constant base in my problem, and the second that I see a constant base, I know I'm going to be using this formula right here, which is the integral of a to the u du is equal to a to the u over ln a plus c. So I just need to identify my u and make sure my du is there. So if I do this, the u is just going to be my exponent, so we're going to let u equal ln x, which means du is going to be 1 over x dx. And you'll notice very nicely I do have 1 over x dx. I'm ignoring the 2 right now because that's a part of the formula. So if I go to rewrite this problem, I actually have 2 to the u du. And then if I follow the formula, it's going to be a to the u, so it's going to be 2 to the u, which is natural log of x, over the natural log of a, so it's going to be over the natural log of 2. And instead of putting a plus c, I'm going to evaluate it at 5 and at 1. So this is going to be 2 ln 5 over ln 2 minus 2 ln 1 over ln 2. And then if I work this out, I know the natural log of 1 is 0. 2 to the 0 is equal to 1. So now I have 2 to the ln 5 over ln 2 minus 1 over ln 2. And I could go one step farther because I noticed that they both have an ln 2 on the bottom. So I'm going to factor out a 1 over ln 2. And if I do that, I'll get 2 ln 5 minus 1. And that would be my answer.